In this video, we're going to show how to transform uncorrected mass measurements into a buoyancy-corrected mass data. And so this is for when you're making measurements of water using an analytical balance. So what we have here are 4 separate measurements of 10 milliliters of water collected using different types of glassware: graduated cylinder, volumetric flask, volumetric pipette, and a Moore pipette. So these are the uncorrected mass values for those water deliveries that were recorded using an analytical balance. Now we want to do a transformation using this equation down here to correct for buoyancy. And so looking at this equation here, it looks like this would be a pretty complicated, convoluted sort of equation to type into your calculator. And furthermore, if you have large amounts of data, it would be very cumbersome to be able to transform all of your data using this equation. But using Excel, it's actually quite an easy transformation. So how we do this is first we'll want to copy over our old data. So we'll select all of our data here by left click and then selecting all the data, Control C to copy. We'll move over to some empty cells on our Excel spreadsheet, Control V to paste them. And then we'll change our header here to just make sure that we are keeping everything accounted for. We're going to change that to buoyancy corrected mass measured. So this would not be measured directly. This would now be the buoyancy corrected mass. And then we can go ahead and delete all of our old data. So now we want to input this equation here where we have each of our different adjustable parameters. M is going to be our corrected mass. The M prime here is going to be our measured mass, so that's the mass measured directly from the analytical balance. We have the D sub A, which is our density of air, which is given to us. D sub W, which is our density of the balance weights. Okay, so that's inherent to the analytical balance itself, and so that's given to us again. D sub A, again, density of air, given to us. And then we have this D sub O or D sub naught, which is the density of the object being weighed. And so we collected these water measurements at a temperature of 22.1 degrees Celsius. So if we take a look at our density table versus temperature, we can see that the density of the water we measured is 0.997747. So we have values for all of these different adjustable parameters for this buoyancy calculation. So now we simply need to make an equation within Excel to be able to input this equation and apply it to all of our data. So to do this, we first click on our replicate 1 for the graduated cylinder, and we're going to press the equal sign to start our equation. So the first part of this equation is simply the measured mass. So we're going to left click right onto the first set of data. Now this is going to be a multiplication here by this fraction here. So we have to put a star for multiplication. And then next we're going to open parenthesis to do the top part of the fraction. And we're going to say 1 minus. And then so since multiplication and division are a higher order operation than addition and subtraction, we do not need a parenthesis to open up to do this division transformation here. So we can simply just input the D sub A, the density of air, which is given to us here, 0.00120, and then divided by D sub W, which is 8.00. So now we'll close that fraction, divide to get us now to the bottom of the equation. Again, we have to open our parenthesis to open this, 1 minus, and directly input D sub A, which is 0.00120, divided by, for the bottom, this D sub O or D sub naught is going to be our density of the water, which will be 0.997747. Close parenthesis, and we have the whole equation input now, and then we press enter. Okay, so now we want to transform this equation to our entire set of data. So the way to do that is when we highlight that piece of data there. We now have the box highlighted in green, and we can see that our cursor here is a white plus sign. If we go to the bottom right-hand corner of this cell, you can see that our plus sign turned black, going from white now to black. If we left click and drag down, drag to the side, and then also, we can see we've transformed all the data across our rows. And then we can go down now by, again, turning our cursor into a black plus sign, and then we can now drag down. So we can see here that all of these pieces of data now have been corrected for that buoyancy calculation. The last thing we can see here is that all of our measurements that we made previously using the analytical balance have 4 decimal places. Here we can see that the decimal places are kind of all over the place. So what you need to do, with home checked up here, you want to go over to the number tab here and to adjust the number of decimal places. And so we can either increase or decrease the number of decimal places. We want to adjust that to 4 decimal places so that we are in alignment with what we actually measured using the analytical balance. And so just a quick comparison between these two values. You can see that the buoyancy correction really does not alter the data very much, but it's important to keep this in mind when you're making when you're making measurements that require very high accuracy and precision.